So you see here, so we already studied what is wave motion and what is wave speed, and as well as amplitude, crest, trough, and differences between longitudinal waves, transverse waves, and XYZ and all. So now today we are going to practice, but of course, a small thing I'm going to say you, that is what we used to call it as a pulse. So after studying this pulse, we'll get back to the work. So you can see that what do you mean by a pulse means? So basically, if you go to hospital, they'll say your pulse rate is low, your pulse rate is high, like that. Do you remember heartbeat? We used to call it as pulse rate. Am I
Yes, sir.
right? Yeah.
Within
So
16
yeah,
seconds, automatic.
yes, yes. So here also same thing. So actually, what do you mean by pulse in the sense of a small, like a disturbance, which is
பல டீ காஃபி குடிக்கிறிய டீ குடிக்காம
Mr. Sam, focus on work, Sam. Yeah. So what do you mean by pulse means any kind of a disturbance which is lasting for a very short duration. So that is what we used to call it as pulse. So pulse in the sense of if you take any kind of a disturbance which is for a very small duration of time. A disturbance lasting for a short duration. That is what we used to call it as pulse. So it is also a wave, but very, very short duration or short period of time, it will disappear. That is what we used to call it as pulse. Okay, then same way, you all know wave speed.
Sir, like rope
Yes,
within few seconds.
yes, ma'am. So you can take, for example, the wave is here. So now it is started. So after just a few seconds of time, it has been disappear and it has been went somewhere. Again, few seconds of time, it has been disappeared. That's all. So this is what we used to say is pulse. Okay. Yes. So just within short period of time, it will be disappear from the things. That is what we used to say is pulse. So then we all studied wave speed. So wave speed, what is the formula, everybody? Wave speed is equals to wavelength divided by time period, or wave speed is equals to wavelength into, yes please, wavelength into, wavelength into what, Ra? Don't know, nobody knows how.
Frequency.
Frequency. So now, let us define what is wave motion. So, and then we'll continue the things. So, what do you mean by wave motion means? So, we all know if you notice it, if you take transverse wave, if you take longitudinal wave, whatever it is, what exactly transferring? Anybody? What exactly transferring? Yes, please. Energy is transferring. So, that is only ways to call it as wave motion. The transfer of energy, the transfer of energy in the form of waves is known as wave motion. Okay, so this is a very, very important one. So when you should remember that whenever the energy is transferred in the form of wave, that is what we used to call it as wave motion. Further only we'll calculate that wave motion in the form of speed. So at what speed it is going, that is what we used to say is wave speed. So wave speed is equals to, that is lambda by time. Lambda is actually what? Distance travel. Time period is what? Time taken for one wave. So that is you have to remember it. So this is all we studied. Now if you look here, uh, wave speed, velocity, if you take like temperatures. So temperature is directly proportional to wave speed. If the temperature increases, suppose if you take at 0 degrees Celsius, at 22 degrees Celsius, at 25 degrees Celsius. So what is the speed at 0 degrees Celsius, everybody? 331, 331 meter per second. Am I right, Sanjay? At 22 degrees Celsius, how much? 340
44.
meter per
Oh.
344, I think, yeah. And 25 degrees Celsius, 346 meter per second. So from this I say wave speed is directly proportional to what? Everybody.
Temperature.
Wave speed is directly proportional to temperature. So temperature rises, the speed of the medium is also, yes please, rise. Okay, clear? All of you? Yes, please.
Yes, sir.
Yeah. Next. Anything doubt you can ask me. Still here. So otherwise we'll continue. So let's start now. Everybody. Yeah. So read the question. First question. A source of longitudinal wave vibrates. A source of longitudinal wave vibrates. A source of longitudinal wave vibrates 320 times in 2 seconds. A source of longitudinal waves vibrate 320 times 320 times in 2 seconds. 320 times in 2 seconds. If the velocity of this wave is, if the velocity of this wave in the air is, if the velocity of the wave in this air is 240 meter per second, 240 meter per second, find the wavelength of the wave. Find the wavelength of the wave. So they have been given wave vibrates 320 times per how many seconds, guys? 1 second or 2 seconds? In 2 seconds. So they are asking now wavelength. So we all know wave speed is equals to wavelength into, speak everybody, wavelength into frequency. But they have given, you see that, they have given the vibrations per how many seconds? 1 second or 2 seconds? Everyone?
2 seconds.
2 seconds. But we all knows that frequency for how many seconds will take? Frequency means number of vibrations per how many seconds, Amma?
1 second.
Vibrations per 1 second.
1
That is
second.
what we used to say. 1 hertz is equals to 1 second inverse. Hertz is equals to 1 second inverse. So now 322 seconds is equals to 320 vibrations. That is
The
what?
320 by 2, sir.
That's all. Then 1 second is equals to 320 by 2, which is equals to how much? Everybody. 160 hertz. That is only the frequency. So wave speed is equals to wavelength into frequency. So wavelength is equals to wave speed divided by frequency. Mr. Silas, are you doing? I want response. Not doing means you can no need to join. So 340 meter per second divided by, this is 160. Hertz means what? 160 second inverse. So 160 second inverse. So second will get cancelled. So 0 will get cancelled. So 24 and 16 both are divisible by some table. What is that? 4 table. 4 fours are? Yes, please. 4
6.
6 are. Again 2 table. 2 twos are? 2 threes are. So 3 by 2. So 3 by 2 meters. What is the unit of wavelength? Unit of wavelength meters only. Am I right, everybody? So 3 by 2 meters means how many meters? 1.5 meters. Wavelength is 1.5 meters. Somebody call to Alfin. Hasni call to that Laksha. What is happened? Completed? Anything doubt you can ask. Could you completed?
Yes, sir.
Right, next question. A distance between any two successive antinodes or nodes. That is what we can say is crust or trough. Okay, Hasan, leave it. The distance between any two successive antinodes or nodes, antinode antinodes or nodes. Nodes means you can take crust and means and trough. Antinodes of a stationary wave is 0.75 meters. 0.75 meters. If the velocity of the wave is 300 meter per second, 300 meter per second, find the frequency of the wave. Find the frequency of the wave. Clear? Yes? Successive antinodes. Successive antinodes or antinodes means anybody? Yes, please. Successive antinodes. So, you people don't know, correct? Now I'll teach you. So, successive antinodes and nodes means, I'll teach you. So, observe very carefully. Antinode means crust, node in the sense of that wave I will draw and I will show you. So, please remember, if I take any kind of a wave, so we all knows that this is what we used to call it as generally a transverse wave. So what is this call it as, everybody? Crust. This is also what? Crust. And this is what? Trough. This is also trough. And this is again crust. And again this is trough. Now antinode. The question is, what is the question they have given? Everybody. What is the question? Everyone read. The distance between any two successive antinodes or nodes of a stationary wave is 0.75 meters. So antinodes are nodes, successive antinodes. So node in the sense of you can draw the wave. You don't know, correct? Crust and trough only you know. So nodes in the sense of this is what we used to call it as node. This is also we can call it as node, and this is call it as antinode. Antinode. So please note it. Antinodes and nodes. Okay. Clear, everybody? So anything you can take. So antinode and node. Whenever the wave will come to the mean position, node. Whenever it will go to the antinode. Again, node and antinode. Node, antinode. Node, antinode. So all these crust and troughs, we used to call it as nodes and antinodes. And mean points, we used to call it as a what? Everybody. Yes, please. Nodes. Okay. Nodes and antinodes. So now they are saying that the successive antinodes are nodes of a stationary wave is 0.75 meters. So, and velocity is 300 meter per second. What is the frequency of the wave? They are asking. So what we have to do it now? Anybody? What is the formula? Wave speed is equals to wavelength into what? Wavelength into what, guys? Don't know.
Frequency.
Frequency. So now, they are giving distance between two successive antinodes. So if you take nodes and antinodes, so this is what we used to call it as a node, and another one is antinode. So successive means what? Side by side. So side by side if you have been taken, so all of you see that the distance between two successive crusts, we used to call it as a what? Anybody? What do we used to call? Can I start the class? Am I audible?
Wavelength.
Wavelength. So, or the distance between two successive trough, what we used to call? Wavelength.
Wavelength.
Or we can say the complete wave, the one crust and one trough. That is also we used to call starting point of a crust and ending point of a trough. That is also we used to call it as a what?
Wavelength.
Wavelength. Now, here you see is actually here, sorry for this, you just modify the distance between antinode and a node. Antinode and a stationary wave is 0.75. So, if I take suppose, all of you observe, if this is the wave means, now you see crust and successive trough. What is the distance between them? Anybody can tell me? This distance is how much? All of you?
Lambda by 2.
Lambda by 2. I already taught you and you should know. Then from this trough to another crust, what is the distance? Everybody. That is also how much? Lambda by.
Lambda by 2.
So please remember the distance between the crust and immediate trough is lambda by 2. Then immediate trough and the next crust is also will become what? Lambda by 2. So for example, I'll say the distance between the crust and immediate trough is, for example, let me take the crust and immediate trough. The distance between is, I will take, for example, 2 meters. Then what is the wavelength? Anybody?
4.
How much?
4 meters.
4 meters. Why? This 2 meters is a what actually? Lambda.
Lambda by 2.
Lambda by 2 is equals to 2 meters. Then what about the lambda? Lambda is equals to 2 into 2. So how much it is? Everybody. Lambda is equals to 4 meters. So that is you have to remember. So here they are saying the distance between two successive antinodes or nodes of a stationary wave is 0.75 meters. So they are asking what is the frequency. So we all know frequency is equals to what, everybody? Wave speed divided by wavelength. So what is the wave speed given? 300 meter per second, and wavelength, antinodes if you take. Antinodes means what? This is the antinode and this is the antinode, and this is the node and this is the node. Okay. So you can take antinodes. Let me take it. It is antinodes only. So the distance between the antinodes of a stationary wave is 0.75 meters. So that is the wavelength. So wavelength is 0.75 meters means how much is the frequency? Everybody. Yes, please. Meters will get cancer. So tell me the answer. Wave speed frequency is equals to how much? All of you? Division you don't tell me. Don't know.
400, sir.
Yeah. Make it quick. Zayan, good morning, Zayan. So what is the answer, ma?
400 meter.
Good morning.
Okay.
400 seconds, sir.
400 seconds, meters, frequency. Frequency means what?
400 hertz.
Hertz. So 400 second inverse will come. So 400 second inverse. Second inverse means what? Hertz. Clear, everybody? Yes? Next question. All of you write. The fundamental frequency of a structured spring. 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 Structured string fixed at both ends is 50 hertz. Fixed at both ends is 50 hertz. 50 hertz. If the velocity of the transverse wave created in string is, if the velocity, again I'm repeating, the fundamental frequency of a structured string fixed at both ends is 50 hertz. Frequency is equals to 50 hertz. If the velocity of a transverse wave is equals to 10 meter per second, then find the length of a string. That is the question. So have you studied anything related to calculating length? Length in the sense of what? Anybody can tell?
Distance.
Distance. That's what. Very good. So anyhow, I'm saying you the calculating length formula. I'm saying you. So note it, everybody. The frequency is equals to wave speed divided by 2L. This derivation also I will teach you. So this is what is the formula for calculating the length of a string anytime. So from this, if you want to calculate length, now length is equals to what is the formula? Wave speed divided by 2 times of frequency. Is it right? L will come here, frequency will go here. Is it okay, guys? Everybody? Yes. So please learn. Calculating length, this is the formula. So wave speed is given 10 meter per second, and 2 into, what is the frequency given? Everybody? What is the
50
frequency
hertz.
given?
50 hertz.
So length is equals to, so 10 ones are 10 fives are. So 1 by 10. So 1 by 10 is equals to how much, Ra? 0.1 meters. So calculating length of a spring, you have to use this formula. The derivation also I will teach you. Okay. So please remember that. Clear, everybody? Yes, please. Sanjay,
Yes, sir.
completed? Okay. So next question, next formula also I'll introduce. You see that. Write the question. In an experiment conducted to determine, in an experiment conducted to determine the velocity of a sound by the resonating air column method. The first resonating length is noted as 30 centimeter for a tuning fork of 250 hertz. So what is the frequency of a tuning fork, everybody? Sanjay, resonating frequency means the length which will travel the wave. That is what? Okay. Sound traveling wave. Understand, Sanjay? 250 hertz. What is approximate value of? What is approximate value of? What is approximate value of second resonating length, and what is the approximate value of velocity of sound? So two things we have to calculate it here. So let us see how to find it. All of you observe. So nothing is there in our textbook NCERT. You might be notice it when we vibrate tuning fork. Have you remember that the vibrating column side in the air? They have given the figure. Am I right? First page, I think. Second page, you'll be having it. You understand, Sanjay? That is only called it as resonating air column. Okay. So the fundamental frequency of the air column, how much they have given? What is that? Tuning fork frequency, how much it is? Yes, please. 200 and 250 hertz. That is the frequency of the air column. Generally, the tuning fork, whatever the frequency of the tuning fork, the air also will vibrate with the same. That is what. So what is the length of the air column? Length of the air column, how much given? Initially, how much it is length vibrating air? Which is about 30 centimeter. Okay. Now, second resonance, you can see occurs when the air column vibrates in like how much they're asking, what is the wavelength of the how much approximate resonant length for the second time vibrating. So here you remember the second time vibrating resonating length is generally for any kind of tuning fork 3 times of initial resonating length. But the derivations and all, it is not there for your book. For foundation only it is. That's the reason we are not discussing, but we will discuss that one. Okay. So keep it in mind. The second resonating length is generally like we can say 3 times of the initial resonating length of any kind of a tuning fork. So now initially it is resonating 30 centimeter. Then what is the second time? How much it will be increases? 3 times means how much it will come in? Everybody. Yes, please. 3 times of 30, which is equals to 90 centimeter. So now, in these situations, because two different length. First resonating length is 30 centimeter, air column is 30 centimeter. And the second resonating length is, after this immediately I'll teach the derivation. Second resonating length is 90 centimeter. Now in this situation, if you want to find the velocity of sound, the formula is 2 times of frequency into final length minus initial length. That is what resonating length, second resonating length minus initial resonating length. So which is equals to 2. Yeah, Mari.
So if there is an alternate case, sir, if they give the velocity of speed, sir, speed of waves, sir, and length one, sir, they are asked us to find the length two, sir. Can we
We
do
can
it
find
that way?
it. We can find it now. That's what I will teach you the derivation so that you will understand now. Okay. So 90 minus 30. So which is equals to 2 into 250, which is equals to 500. 90 minus 30, how much? 60. Yes. So that is only. So 5 6 the 30. So 30,000 centimeter per second. That is what is the waves velocity of a sound. So now let us go for the derivation of this one so that you will all understand how to find the resonating length. That is what we will see that. So like first harmonic, second harmonic, third harmonic. So whatever it is. So generally waves, if you notice it. So I will go with slowly explaining also. You can see that. So generally wave will start at a particular point. So you can take a air column. So this is my R column. So let me consider now, if I take wave is started here. So this is the first harmonic wave, it will goes. So first note. So let me take T is equals to, if I consider, sorry, L is equals to, I will consider length is equals to lambda 1. Now second resonating wave. So second resonating wave means it will be coming to the what node. So if I take again second resonating wave. So first wave started, it will go and will come to the node again and it will be again started. So this is what is that. So second resonating wave. So it will be basically, I told you already, L is equals to 3 times of lambda 2. Okay, 3 times it will increases. That formulas, derivations. Then third resonating wave. If I go to the third resonating wave, it will be what will happen? First one, second one, and third resonating wave. If I have taken third time the wave is repeating. Okay. So third time wave is repeating, then length is equals to 5 times of lambda 3. Okay. So this is the concept. So for this also there will be derivations. But that is all. If I take into that, then it will like 11th class concepts it will becomes. Then it is very tough to people understand. Then fourth resonating. If I take the fourth resonating. So fourth time the wave is repeating fourth time. The tuning fork. First time 1 and second time and third time now. So third time and then fourth time. If it is repeating the fourth time, then the length is equals to 7 times of lambda 4, length lambda 4 divided by 4. So for this all there will be derivations. So that's why at least second resonance we'll learn. That is enough for us. So first resonance and as well as what? First resonance and second resonance. Okay. So first resonance lambda 1, length is equals to lambda 1. Second resonance 3 times of lambda 2. So this is what it is. First resonance, second resonance. So now, if you have been taken here, so what will happen? First resonance and second resonance. If you calculate the formula, wave speed is equals to 2 times of frequency into second resonance minus first resonance. This is the formula for calculating first note and second note. If you go for a third one, fourth one, then you have to do this subtraction. So this is the first resonance and second resonance calculating wave speed. Formula is 2 into frequency into second resonance minus first resonance will give you the wave speed formula. That is what you have to remember. Okay, everybody? Yes, please.
Yes, sir.
Okay, now, till now, you have seen that we have studied in the last chapter pendulum. Have you remembered pendulum for what we studied? Anybody? Pendulum. Simple pendulum we have studied for something. Anybody can tell me? Simple pendulum. Energy transformation. It will go from mean position to extreme position and again from extreme position to another extreme position. So when it will comes from mean position to extreme and extreme to mean, then we can say what? How many vibrations?
1 hour.
One vibration, or we can say one oscillation. So now let us see that in this case how to find the time period and all. So write it everybody. The average speed of the bob of a second pendulum is the average speed of the bob of a second pendulum. The name of the pendulum is second pendulum. Second pendulum is 2 meter per second. Determine A, linear amplitude or amplitude. Both are same. Linear amplitude. B, frequency of the oscillation. Frequency of oscillation. So these are the two things we have to find it. So can you give anybody idea, please, how to solve? Both are same. You can just simply solve it. So we all know